electric field and uniform charged plastic pipe. The plastic pipe has inner radius, so let's say the inner radius is A. Okay, so the inner radius is equal to the 0.37 meters, and then we have outer radius, let's call it B. So the outer radius is equal to the 0.76 meter. The electric charge is uniform distributed over the region. The charge density in this region is, so the charge density is equal to the 16 coulomb divided by meter cube. Calculate the magnitude of electric field. Electric field when R is equal to 0.23 centimeter. This is first part. Okay, so let's continue. So this is L, so this is, let's say this will be our H, height of this cylinder. So the rho is equal to the Q total charge divided by the volume, right? And from there we can say Q is equal rho times V. Now V is equal to what? V is equal itself is pi H, let's say R outside squared minus R inside squared. Okay, then what else? Then we have electric field times area is equal Q divided by epsilon naught. From there we can plug what is a Q here, so it's rho V is equal to the pi H R outside squared minus R inside squared divided by the epsilon naught. Now we can say that our E is equal rho pi H R outside squared minus R inside squared divided by the epsilon. Now what is area? Area is basically area of the Gaussian surface. Let's say we want to do Gaussian surface, let's say outside of it. Okay, as an example. So that one will be what? First of all, you take the lens, right? The lens, okay, of the circle, which is 2 pi R. This will be like this R, okay, R, and the height, okay, 2 pi R, and then this is length times H. Okay, so that means what we have here, the pi cancels, H cancels, so finally we end up with the formula which is E is equal rho R outside squared minus R inside squared divided by epsilon naught, okay, 2 epsilon naught and R. This is R of the Gaussian surface of the, okay. So let's solve the first part. In the first part, what we have? In the first part, we have to find electric field when R is equal 0.23. So that means if you try to draw it inside where R is 0.23 meters, okay, 0.23 meters, as you can see, there's no charge inside this at this radius 0.23 meters, so therefore electric field is equal when R is equal 0.23 meters. Okay, now what about second part? And the second part, we have to find electric field R is equal, so the second part, R is equal to 0.56 meter. Now 0.56 is in between like, so let me draw the Gaussian surface, and this radius is basically this radius is equal to the 0.56. Okay, so how can we find it now? Again, we use the same formula. Electric field is equal rho. Now R outside obviously will be 0.56 squared minus R inside. Inside means the A length, which is 0.37 squared, divided by the 2 epsilon naught, and R is basically the radius of the Gaussian surface, which is 0.56. So if you plug numbers, you should get the answer. Now the final part. So let me just erase this part. In the final part, so let me select this one. So in the final part, we have to find electric field when R is equal. So electric field when R is equal 1.43 meters, which is this R 1.43 meters. Okay, so now okay, so let me highlight one thing here. So when you have this formula, this R outside and R inside are the limits of the pipe. Okay, charged plastic pipe. Now since our R is Gaussian, this is outside of the pipe, therefore what we can do this time we can say that electric field is equal rho. Now R outside of the radius, which is B squared minus A squared, and divide by the 2 epsilon naught. Now R is the radius of the Gaussian surface, so that means we put into the R will be 1.43 meters. Okay, so that's it.